starting doing quadratics. We did tons of quadratics in almost every section in Chapter 1. So we know how to solve a quadratic equation, and we'll use all of that here as well. Okay, so we're sort of going back. We're just adding one more part to a quadratic, and that's how to actually graph a quadratic function. So we're just going to jump right in. Number one, if we said y equals x squared. So last week with my daughter, I was doing, she's doing order of operations in school. So to make it more fun for her, for practicing at home, then I showed her how to graph parabolas, and then I will show you in a minute what I had her doing. And the actual graph of the parabola was her check to make sure she did order of operations right. So I'll show you that in a minute. First of all, what is a parabola? What's it look like? Yeah, U. Okay, what's important about a parabola is that you don't make it pointy. What's a pointy graph? What would that might be the graph of? Do you know? Which we'll see in the next part. If it's like a V instead of a U. That would be an absolute value. It's like a V. A parabola is like a U. So they do have different graphs. Okay, let's make a table of values. So it's old faithful. You can always revert back to a table of values. Let's plug in 0, 1, -1, 2, and -2. So I'm saying for the x, the value is 0. So 0 squared is 0. 1 squared, 1. -1 squared, 1 again. 2 squared, 4. And -2 squared, 4 again. Okay, let's plot these points. So here's our x-axis and our y-axis. So these are points like x, y. So 0, 0, the origin. So 1, 1. And 2, 4. Okay, so if you were showing my daughter what a parabola looks like, let's connect these. What would you tell her about the graph? What could you say about it? Any ideas? Symmetric? Is that what you said? Or am I making it up? I didn't actually hear you, but lip reading. So, symmetric, what does that mean? Yeah, it's like a mirror image or the same on both sides. What's it symmetric around? The y-axis here. Let's call this the vertex. So we say that bottom point's called the vertex. And do you see these points match on either side? That's always going to be the case, so it's symmetric. If you find a point on this side, you can find one equal height on the other side, the same distance away. Okay, so that's always the case. Do you see that for two x values, there's the same y value? We can find two more x values that have the same y value. No matter how complicated I make the parabola look, the equation, that's always happens, except for one point, which is in this one, 0, 0, which is the vertex. So every parabola sort of works the same way. So this is what I had her doing. I gave her an equation something like this. I put some brackets and things in it, which we'll get to later, but a little bit more complicated than just x squared. And I showed her how to plug an x value in. I made her a little table of values like this. And so each of these questions, say we wanted to plug in some points. Okay, I wrote the x values down like I did up here, and then she had to write each equation and solve it. And that's order of operations. You square it first before you add the 1, right? You do each of these terms separate, and then you add them all together. So then she was getting numbers, sometimes wrong, because she was just learning how to do that. But when she draws the parabola, she would know if it wasn't right, if it didn't look like a parabola once she put all the points on. right? She said, oh, I can't connect these dots. I said, okay, which one is weird? Go back and figure it out. Okay, so before I pick the values for this one, to find the vertex, you need to know how to find the vertex so that you can find points on either side of it. Okay, so that's one important thing. So the vertex itself, I mean, we could just plug in some random points and hope that we don't get one with a match, but not a good strategy. Okay, we can plug in some numbers and hope we do get a match. If we had one that matches, how would we know what the vertex is if we stumbled upon 2 points like this? By just making a table of values. How would we know where the vertex is? No. It does in this case, but that wouldn't be it. Remember, it's symmetric around that vertex. So it would be whatever x value is right in the middle of those. Right? If this is a positive 2 and this is a negative 2, those values are 4 units apart. 1, 2, 3, 4. So right in the middle at that 2 mark is the 0. And then you could plug in 0 and find the y value. So if you know what the x value is of the vertex, you just plug it into the equation and find the y value. So if you did find 2 points that were equal height, you could say, okay, what's the middle of those? And do it. But that's not a really good strategy. So the vertex, there's a formula for it. It comes from the quadratic equation. It looks like this. Now, it comes from the quadratic equation. What was the quadratic equation? So where is this in that quadratic equation? Do you see the minus b over 2a? And forget about the square root part. So it's not a new formula, it's just forget about the square root part. That will give you the x value of the vertex. So in this case, what is a and b? So the c doesn't matter to the vertex, just the a, in this case, would be 1 in front of the x squared. The b is 2. So if we plug that in, minus 2 over 2 times 1, we get negative 1. So negative 1, this is going to be the vertex, that point. Now all we need to do is find a point on either side of that, and it'll give us the equal height. So if negative 1, just draw an x and y axis here. Negative 1 is over here. So the vertex is going to be somewhere around there. We don't know the y value yet. What's a point, say 1 in the positive direction? Like if you added 1 to this, where do you go to? Here's negative 1. If we go 1 over, 0. And what if we go 1 in the other direction? Negative 2. Since those are equal distance from the middle, the y values will be the same. Unless you messed up the vertex, and then it won't be. But if you go equal distance from the vertex in either direction, you'll always get a point that's the same because it's symmetric. All right, so let's plug these in. So here's our equation. Remember, take the x's out. And if you get messed up with signs, maybe take the x's out, put brackets in their place, and then plug your number in. So here we want to plug in x is negative 1, so you put negative 1 in those brackets to make sure that you do the right thing with the signs. Negative 1 squared is 1. 2 times negative 1, and then plus 1. What's this give us? 0. So the vertex is the point negative 1, 0. That is right here. So that's the vertex. Now, if we plug 0 in, what do we get? Zero squared plus 2 times 0 plus 1. 0, 0, and 1.
Is the vertex on the next axis?
Nope. Yeah, our next example won't be.
I didn't think so.
Yeah. Yeah, our next example won't be. And negative 2? negative 2 squared in a bracket. Negative 2 times negative 2 is 4. Positive 2 times negative 2 is negative 4. And does that give us the same value as the other one? Yeah, 4 minus 4 is 0 plus 1, which is what we wanted. I picked a point on purpose that would happen. It's kind of like a check as well, right? If you can get a point on either side that the height's the same. So here is our point, 0, 1. And on the other side, negative 2, 1, the same height. Since that's the vertex, it's going to be the bottom of our U shape. And it goes like that. All right, so of course there's more to it. If it's not on the axis, then it's more complicated. So I just did two that were easy first. And of course it's more complicated if the vertex is not on the axis. So that's what we'll do next. And basically this is all you would need to be able to do for calculus and complete the square, which is the next section. Because you, again, with the graphing, this whole chapter, what you need in calculus is to know how to graph the graphs relatively quickly and with points that make sense. So it's going through at the right point. We don't want to do it on graphing paper because you're going to take the graph and do something with it, and you don't want to stop and get graphing paper. You want to be able to do a quick but accurate graph. So a couple points, and you notice I didn't even label the tick marks. I just put the points I need in, and so they're relative to each other. Okay. Number 3. Now we'll go from easy to kind of hard. Fractions. All right, so step 1, find the vertex. So here B and A are both 1. So minus 1 over 2 times 1, negative 1/2. So step 1, find the x value of the vertex. Step 2 would be to find the y value so that you actually have a point for the vertex. Find the y value by plugging x equals negative 1/2 into the original equation. Like we always do for any point on any graph, just take your x value and plug it in. So here we would have y equals x squared plus x minus 2. So what did I do? I took the original equation, took all the x's out, put brackets in their place. Then what? Put the negative 1/2 in. Very carefully, we're going to have to negative 1/2 squared. So the negative it's going to be negative times the negative, positive. And to square a fraction, you square the top and you square the bottom. So 1 squared over 2 squared. So what would this be? 1 squared is 1 over 2 squared, 4. And it's positive because 2 negatives make a positive. Nothing to do to this one. So we can just get rid of the bracket. Common denominator. That 2 is like over 1. So we'll multiply this one by 2 and this one by 4 so that they're all over 4. Now that they're all over a common denominator, we can work out the numerator, the top. So here's negative 10 plus 1, negative 9 over 4. So our vertex okay. Now, at this point in the last question, I said, here's your vertex. Let's just go one in either direction to find the 2 other points. Not as nice here. You could do that, but we're not going to. So what we're going to add to the question now is the intercepts, because you're going to have to find the intercepts. And if the vertex is not on the x-axis, then there are intercepts probably. going through the x and the y-axis. So we're going to add that to our steps. So let's say step 3, find the x and y-intercepts. Same way we did for the linear equations, but now we've got quadratics to solve. So the y-intercept is actually the easier one. To find the y-intercept, we let x equal 0 in the equation. So if we write that down, y equals x squared plus x minus 2, putting zeros in there, what do we get? Minus 2. So we have a point 0, minus 2. X is 0, and we just found y is minus 2. Write the point down right away. I explained why last time. When you look back, if it's not written as a point, you kind of might get that mixed up. Now what about the x-intercept? What do we do? Now, of course, this is trickier. Like that. So then what do you say to yourself? Now we've got a quadratic equation. Always has to equal 0. That would be the first thing, which we made it equal 0, so that's good. And then your choices are to either factor it or use a quadratic equation. So, does this factor? Yep. Plus 2 minus 1. So we get x plus 2 equals 0 is minus 2, and x minus 1 equals 0 is 1. What does this tell us when we got two values? Two x-intercepts, which is the case, except for in the last example, where the vertex was the intercept, minus 2. And that's like, there's two x values that give you the same y value. That's the symmetric part, right? They're equal on either side, so there's 2 for every y value, except for the y value for the vertex. Every other point has a match, and we just found the match for that one. All right, so let's graph it. That's all we need. We don't need to do a table of values unless you want some extra points. So the vertex first. So negative 1/2. Let's look at our points. We're going x values 1, negative 2, and negative 1/2. So they're all, so let's say 1, 1, 2. So negative 1/2 would be in here. And what's the y value for that vertex? How many times does 4 go into 9? 2, with how many left? 2 would be 8, so there'd be 1 left. So it's negative 2 1/4. So 1, 2, or sorry, down. Negative 1, 2, and a little bit. So you write that point on there. And then add your other points. So 0, negative 2. That's this one. And then negative 2 on the x, 0. And 1, 0. Now the vertex, keep in mind, which is always your vertex, that point we don't have a match. What would be the matching point for this one? Any ideas? Without plugging anything in. How far is this between here? 1/2. So if we went 1/2 in this direction, where would we be? Negative 1. So there would be a point there. Your vertex is at the bottom, and your other points are symmetric. I didn't even write that in, but you can think about there being a point there. You don't really need to find it. Okay, I was just asking to see if you could, but you don't really need to actually find what that point would be. But just remember that they're all even. Okay, so if there's one on one side, going to be an equal one on the other side. Okay, so here we go. And that's more likely what we're going to have to do. Find your vertex first, x and y value, then find your intercepts, and then you graph it. Okay? So the vertex doesn't always work out to a fraction. Sometimes it works out nice, but we wanted to add that in there. Now, what about this one? So it's still an x squared, so that's how you recognize that this would be a parabola, but it doesn't have the plus c, which is fine. It's still a quadratic. This one, and when we factor it, we wouldn't factor a trinomial, we'd do a common factor instead. Okay? So we would start the same way, so find the vertex. X equals minus b over 2a. So minus b over 2 times a. Plug it in to find your y value. (2x squared plus 8x). Put the negative 2 in. So 2 times negative 2 squared is 4. 8 times minus 2 is negative 16. Vertex. Okay, so that's step 1, step 2, step 3, our Y-intercept. That's the easier ones. We let x equal 0. What do we get? 0. 0, 0. So it just means that it goes through the origin. Now what about the x-intercept? Take out a 2x. I'll just put the 0 on the end instead of the start. So the 2x that equals 0 gives me 0. That's the point we already know, because that's both an x and a y-intercept if they're both zeros. So we already have this point. This one, negative 4, and y is 0. So the x and y-intercepts are, one of the points are the same, because they both go through the x and the y. And then we'd graph it. Put your vertex on first, negative 2 and negative 8. So you don't need to go down 8 tick marks. What could we do instead? What's our other y values? Look at our y values here. What are they? Just all 0. So negative 8 really is the only y value? Right? It's the only y value we have. We can just stick a negative 8 on here. Okay, like you don't need, you can put 2, 4, 6, 8, but you don't need to. You've got 1, and that's, anything else would be around that. Okay, and our x values go down to negative 4, and there's no positive x values. Okay, so negative 2, negative 8, 0, 0, and negative 4, 0. And that's the symmetric part. Make sure it's rounded at the bottom, not pointy. Now, these ones are actually really easy, but we're going to go through the same process, okay? So the next two are so we did a trinomial, 3 parts, and then we did a binomial, the 2 parts, but it was like a common factor. What type is this if we were factoring it? Difference of squares, and then the next one we'll do will be a sum of squares that doesn't factor, okay? So to see all the different cases. So the vertex. What's A and B? Right, B is 0 here because that x term is missing. So when we do the vertex minus B over 2A, we're getting 0. 0 on top's okay, it's 0. So x is 0 will be y is 0 will be the, x, yeah, that's silly of me. I was recopying. That's the x value of the vertex. Find the y value. So y equals 0 squared minus 4. Now I said we're going to go through the process, but these ones are really easy and you shouldn't go through the process for these. What do you see here? If it is just like an x squared minus a number, or even plus a number, that is the vertex, 0, negative 4. Always. Because if the b is missing, that's what moves it and makes it not a 0, the x value. So that would move it to the left or right. This is just staying at 0 and then going down. So this graph is just going down, negative 4. We'll see that in the next section more, but the process itself will still work out for you. 3, the Y-intercept. But x is 0, we already have it. If we plug in x is 0, right? Again, not necessary because it really is that point. If you plug in 0, you get negative 4. And 4, the x-intercepts. It's a difference of squares. X plus 2, x minus 2. So x equals minus 2 and x equals plus 2. So far, so good? That's all we need. As long as you have the vertex, and even one more point will work because, you know, the other one's symmetric. But the intercepts, you're going to be asked for those in this class. So we want them to go through the axis in the right place. So our y values go down to negative 4. And our x values 0, plus and minus 2. So start with your vertex. And 2, 0, minus 2, 0. That's your vertex, so they should be symmetric on either side. This is the same point, of course. We just, the Y-intercept is the vertex. So they share that criteria. Now what if it was a sum of squares? What happens? That was a difference of squares, the minus in between. Okay, so first of all, go back to this one. This is just the regular x squared, regular parabola, moved down 4. That's all it is. If you took the regular parabola and we moved it down 4, that's what the graph would look like. So this is actually the regular parabola moved up 6. So you could just jump right to the drawing. Okay, but that being said, what if we do go through and try to find all of these? So what's the vertex? So what's B? 0 again, there's no B. So so that's 0. Our y value, so there's our vertex. Y-intercept, that is the y-intercept, x is 0. Right, so the y-intercept, if we let x is 0, well, we already found it, 0, 6. 4 is the x-intercept. Let y equal 0. Don't ever forget, that doesn't factor, right? That has no solution. There's nothing that we can square and add to 6 to get a 0. Squared's always positive, 4, 0. So that is none. So how can it have no x-intercepts? Right, we're going up 6. I'll just say here 6, 0, 6. Now I have nothing else to draw. So is the graph a point? Is that it?
So parabola.
Right, it's still a parabola. So we do want one other point, okay? So even if the process doesn't find another point, how could we find another point to graph it? Table of values, that's it. So we do need another point. And if one didn't come out of finding the x and y intercepts, you can plug in any x value at all. Let's plug in 1. What do we get for y? 1 squared plus 6? 7? 1, 7. Now, why do I only need 1 point? Why wouldn't I need another point? I could do more. Could do as many as you want. Right, they're symmetric. If you know that this side goes like that, then this point has to be in the same place on the other side. Does that make sense? You can find it if you want, but just make sure if you draw one point and you draw that, make the other side look symmetric and it will be right. Right, if that's 1, 7, this will be negative 1, 7. 1 away from 0 on either side. Okay, let's do one that the y-intercept, the x-intercept, we have to use a quadratic equation to find them, okay? Because then we have to plot that point. And that goes back to when we did radicals and we had to estimate where it was. Okay, so 7 will look like this. Y equals 2x squared plus 4x minus 1. Okay, still find the vertex the same way. So minus 4 over 2 times 2. Minus 1, works out nice, it's not a fraction. 2, find the y value. So I just took out the x's, and in their place I'll put a negative 1. So 2 times 1 minus 4. Okay, the y-intercept. That's the easier one. Okay, so I told you what's going to happen with the y-intercept, or the x-intercept, which is, it's not going to factor. Now, next term, when you're in calculus and the y-intercept is, x-intercept is hard to find, you're not going to be asked for it, so I would just say, okay, that doesn't work, I'm going to find other points instead. Okay, and I'll show you how to do that in a second, that it goes through in the right place, even though you didn't find them. Okay? But here, I'm going to ask you specifically to give me the x and y-intercepts, and we know how to do it, so it's not, and sometimes you would need them. But if you're not specifically asked and they don't work out nice, then you wouldn't do that. So here we're going to let y equal 0. Now, you could try to factor it, but I set it up on purpose that it doesn't. So you could try to factor, you say it doesn't factor, so we're going to use the quadratic equation. Remember to put it all over 2a. So minus b, plus or minus, we'll just fill this in, b squared minus 4 times a times c. (16 plus 8), 24, and does that simplify? How do you know if it simplifies? Does 24 have a factor of 4 or 16 or 25, something that works nice, does it? Just 4 goes in. So root 24 is 4 times 6. So square root of 4 is 2, and the square root of 6 we would leave. You had to do this on your test the other day. Yeah, the factor of 2 will go into all 3 of these terms, so we can factor out a 2. The other way I would do it is this. So if we can split it up into 2 separate fractions. This will work good for graphing. You could just factor out a 2, but I would do this after anyway. So what's 4 over 4? 2 over 4, the 6 doesn't cancel, but that goes in twice. Okay, so here's our numbers. They're not nice. We don't have a calculator, and we don't like to estimate what they are. Okay, I'm guessing that no one really likes to do that. So forget about it for a second. We know what they are. Let's write them down as points. So our x-intercepts are the points -1 plus root 6 over 2, comma 0, and -1 minus root 6 over 2, comma 0, because the y is 0, right? So there's our 2 points. I'm going to put them on the graph and write them in because I was asked for them, but I'm just going to make sure they fall between the right numbers, because we're not using graph paper, and we just need it to fall in the right place. So you can do that one of 2 ways. We can estimate what root 6 is, put it in as a decimal, and work it out. But we're not going to do it that way. We're going to do a table of values, okay, instead. So we know the vertex, okay, so we're going to find a couple more points. And the reason I'm doing that is that that doesn't work out very nice. Okay, so I'm just going to add another point in here. You don't have to do that. You could estimate what that is. What's our vertex? -1, -3. And we have a point 0, -1. What would be another point we could put in there that would give us the same y value, say? Let's look at a table of values, or a graph. So here's 0, here's -1. So our vertex is at 0, -1 right here. Or not our vertex, 1 point. Our vertex is -1, -3 down here. Is that enough to graph it? It is, but there's a problem. I'm going to look and say, did these points go through in the right place? So that's what we want to know. Where do those points sort of go through? Well, they go through at negative 1 plus root 6 over 2 and negative 1 minus root 6 over 2. But we don't know what those are. Okay, and we could use a calculator or a guess. What would be some nice values on here, maybe to try to find out where this goes through? What could we try? So here's 0. So we could try 1, right, and see where that is. So if we plug in 1, what do we get for our y value? So our graph was 2 times 1 squared plus 4 times 1 minus 1. 5. So 1 is up here. So does that show where this point goes through the x-axis, between what numbers? Does it show what two x values that's between? 0 and 1. Right? So now I have it accurate that I've got a point on either side of that, and all I need to do is write this point in. Which one would this be? The other one's over here. The plus, right? It's the bigger one. If we subtract a number, it would be the smaller one. So we would say minus 1 plus root 6 over 2, comma 0. Now we've labeled that point. Now what about this side? We have these symmetric points here. Could we say what they are? This is negative 1. So how far over did I get to that point? How far do I move from negative 1 to get to this point? In the x direction, 1. So this would be 1. The y value is the same, but it's over 1. What about this one? Negative 1 plus 1 is 0, plus 1 is 1. What would this be? 1 more in that direction. Negative 3. Okay, I can see a few of you are confused. Here's our vertex. We have a point at 0 and we have a point at 1. If you're counting over, so we have the vertex, we have a point at 0 and a point at 1. Point at 0, point at 1. Going in the opposite direction, what would those two numbers be? Negative 2 and negative 3. Right, just on a number line. Here's our center. And our points will be symmetric on either side. So add 1, add 2. And we can label this point, negative 1, negative root 6 over 2. We know which one it is because this is the bigger one, so it would be further to the right. It's bigger because we're adding root 6 over 2. Here we're subtracting root 6 over 2, so that would be the smaller one. Okay, and there's, in the textbook, read the section. There's tons of more examples, and you can do that whole homework now because we're done 2.4. We'll do 2.5 on Wednesday. Okay?